Section 4.4 is on parallel and perpendicular lines. Parallel lines are two lines that never intersect, and because they never intersect, they will have exactly the same slope. Let's take a look at an example of the sort of problem you'll see in the classwork. This says write the equation of the line that is parallel to the given line and passes through the given point. So here I have the equation of a line, and here I have a point. So I want the equation of a line that is parallel to this one, but goes through this point. So in order to write the equation of a line, I need to know the slope and the y-intercept. Since these two lines are going to be parallel to each other, the slope of the line that I'm looking for is going to be 1/4, because these two lines will have to have the same slope. And I don't know the y-intercept of the line I'm looking for, but I do know that this is an x-coordinate of a point on the line, and this is the y-coordinate of a point on the line, and here's my slope. So I'm going to use that to find b. So starting with y equals mx plus b, I know that the y of a point on the line is -3. I know the slope of the line is 1/4. I know that the x of a point on the line is 4, and what I'm looking for is b. So let's solve that for b. So -3 equals 1 plus b, and subtracting 1 on each side, my b is -4. So the line that I'm looking for is y equals 1/4 x minus 4. So that is the equation of the line that is parallel to this line that I was given here, but it goes through this point for -3. You'll notice, of course, since they're parallel, they do have the same slope, but what's different about them is they have a different y-intercept. Now, perpendicular lines are two lines that form right angles, like this right here. They don't have the same slope, but they have slopes that are opposite reciprocals of each other. So if the slope of one line is 3/4, the slope of the line that is perpendicular to it is going to be a -4/3. If a line has a slope of -7, the slope of the line that's perpendicular to it is going to have a positive 1/7. So let's take a look at a couple examples here. Write the equation of the line that is perpendicular to the given line and passes through the given point. So here I have the line y equals 2/3 x minus 1. So I need a line that is perpendicular to that line, but it has to go through the point 4, 7. So the slope of the line I'm given is 2/3, but that's not the slope that I want to use. I want to use the slope of the line that is perpendicular to that. So the slope I'm going to be looking for is -3/2. And in fact, maybe I'll just cross that one out so I don't get confused. So the slope of the line I have to write is -3/2. So that's going to be my m. And again, I'll use this as my x and this is my y. So if I have y equals mx plus b, the y of a point on the line is 7. My slope is -3/2. A point on the line is 4, and I don't know my b. So 7 equals -3/2 times 4 gives me a -6 plus b, and solving that for b, I get that b equals 13. So my final answer is y equals, make sure we use the perpendicular slope, -3/2x plus 13. So you'll notice, because the slope of the line that we were given is 2/3, and the slope of the line that we found is -3/2, those are opposite reciprocals of each other, so these two lines are going to be perpendicular to each other. Here's another example where we need to find the equation of the line that's perpendicular to 2x plus 3y equals 12 and passes through the point -4, 6. Now this one's a little more difficult because you'll notice this line is written in standard form. I can't just look at it and figure out easily what the slope is going to be. In order to do that, I need to put it into slope-intercept form. That is, I need to write it as y equals mx plus b. So to do that, I'll subtract 2x from both sides. and that gives me 3y equals negative 2x plus 12, and then dividing both sides by 3, I get y equals negative 2/3 x plus 4. Now, all I really want from this line is its slope, and it has a slope of negative 2/3. But if I'm looking for the line that's perpendicular to that line, I want the perpendicular slope, which is the opposite reciprocal, which is going to be 3/2. And that's the one I'm going to use. So let's plug that into y equals mx plus b. And let's use our point, negative 4, 6. So I'll plug in 6 for y, 3/2 for my slope, negative 4 for x, and I need to find my b. So 6 equals 3/2 times 4 gives me a negative 6 plus b, and then adding 6 to both sides, my b is 12. So my final answer is y equals, make sure you use the perpendicular slope, 3/2x plus the b that I found, which was 12. And our last example here asks us to determine whether this pair of lines is parallel, perpendicular, or neither. And in order to do that, I need to know what the slope of each line is, because if the slopes are the same, they're going to be parallel. If the slopes are opposite reciprocals of each other, the lines are going to be perpendicular. And if they're neither the same nor opposite reciprocals, then these two lines are going to be neither parallel nor perpendicular. So basically, you'll notice they're in standard form. I just need to turn them into slope-intercept form. So subtracting 2x on both sides, I'll have 7y equals negative 2x minus 35. And dividing everything by 7, I'll have y equals negative 2/7 x minus 5. So there's one of my lines. Let's do the same thing over here. Solve this for y by subtracting 4x on both sides. So I'll have 14y equals negative 4x minus 42. And dividing everything by 14, I'll have y equals negative 4 over 14 is a negative 2/7 x, and negative 42 divided by 14 is 3. So you'll notice that my two lines, and all we're looking at here is what the slopes are. The two lines have the same slope, therefore they are parallel to each other. So in this section, we took a look at how to write equations of lines that are parallel to each other and that are perpendicular to each other. If two lines are parallel, they have exactly the same slope. If two lines are perpendicular, then their slopes are opposite reciprocals of each other.